Hey Fast Track, in this video we're going to go back to using the hand trick, but this time we're going to do the hand trick with radians. So you guys learned about radians in our last video with the unit circle. So now let's do the hand trick with radians. So for example 1, we're going to evaluate sine of 13 pi over 3. So if you remember from the hand trick video, the very first step is to find the reference angle. So let's graph 13 pi over 3 to help us find our reference angle. To graph 13 pi over 3, you have to label your coordinate plane with pi over 3's. So this right here should be 3 pi over 3. And again, you know that's correct because that simplifies to give you pi. So it's 3 pi over 3. 1 full revolution will be 6 pi over 3. So that reduces to 2 pi, and you know that 1 full revolution is 2 pi. So let's just label these just in case. Half of 3 pi over 3 will be 1.5 pi over 3. So each quadrant is 1.5 pi over 3, making this 4.5 pi over 3. So let's graph 13 pi over 3 to find our reference angle. Start at the positive x-axis and go counterclockwise since it's positive. So we're trying to get to 13 pi over 3. 1 full revolution is 6 pi over 3. 2 full revolutions is 12 pi over 3. We're trying to get to 13 pi over 3. So we're going to go up 1 more. Okay, so our reference angle. Keep in mind that this right here was 12 pi over 3. We needed 13 pi over 3. So remember, the reference angle is the angle from the terminal side where the angle ended to the closest x-axis, which is this one right here. So that right there will be pi over 3. So now let's use our reference angle. So we're going to be doing sine of pi over 3 to evaluate this problem. So remember, we have to go to our left hand and you have to know how to label your fingers. So remember, you are in the first quadrant right now, and in radians this right here is 0, this right here is pi over 2. Go this way, go up 1 and skip 5. So remember, pi over 2, then it's pi over 3. Middle finger is pi over 4. You skip 5 and you go to pi over 6. So here are our radians. So again, we're using pi over 3. So you should pull your index finger back, and we're doing sine. And if you remember, sine is the square root of bottom fingers over 2. So if you have your index finger pulled back, square root of bottom fingers, which is 3 over 2. So the sine of 13 pi over 3 is equal to square root of 3 over 2. But important part, don't forget to check your sine. So remember, all students take calculus. Our angle landed in the first quadrant. In the first quadrant, everything's positive. So that square root of 3 over 2 is positive. Now, for example 2, we are doing the secant. We're evaluating the secant of 5 pi over 6. So we have to find our reference angle first, but keep in mind that secant is the reciprocal of cosine, so we're going to use that in a minute. So let's find our reference angle first. Let's label our axis or our coordinate plane with pi over 6. So this will be 6 pi over 6. 1 full revolution is 12 pi over 6. From here to here is 6 pi over 6, therefore each quadrant is 3 pi over 6, making this 9 pi over 6. Well, we kind of didn't even need to measure those, to label those, since we're doing with 5 pi over 6. So you always start at the positive x-axis. Since it's positive, we're going to go counterclockwise. If from here to here you get 6 pi over 6, but if you only need 5, you stop right there. Remember, the reference angle is from the terminal side to the closest x-axis, which is this angle right here. Since we stopped at 5 pi over 6, and if this is 6 pi over 6, our reference angle is pi over 6. So we're going to be doing the secant of pi over 6. But remember, with the hand trick, we can only do sine, cosine, and tangent. But since secant is the reciprocal of cosine, we're going to do the cosine of pi over 6, and whatever we get, we're going to flip that since we are interested in the secant. So again, let's go to our left hand and let's label it. This is 0 radians. This is pi over 2, pi over 3, pi over 4, skip 5, pi over 6. Now we are using pi over 6, so you are pulling your ring finger back. Cosine. The cosine was square root of top fingers over 2. So we have 3 fingers at the top, so square root of 3 over 2. And again, since we are interested in the secant, which is the reciprocal of cosine, secant of 5 pi over 6 will be equivalent to 2 over the square root of 3. And of course, you have to rationalize. 2 times root 3 is 2 root 3. Square root of 3 times square root of 3 the long way. That gives you square root of 9. Square root of 9 is 3, so your new denominator is 3. And of course, 2 divided by 3 doesn't reduce, so you are done right here. But don't forget to check your sign. All students take calculus. We are doing secant. And our angle landed in the second quadrant. And in the second quadrant, only sine and cosecant are positive. So therefore, our answer is negative. So negative 2 square root of 3 over 3. Now, for example 3, we're doing the cosine of 18 pi over 4. So first thing, find the reference angle. So I labeled my coordinate plane. So let's start. Here is our initial side, 18 pi over 4. 1 full revolution is 8 pi over 4. 2 full revolutions is 16 pi over 4. We're trying to get to 18, so we need 2 more. In other words, we land up here on the positive y-axis. So let's find our reference angle, the angle from the terminal side to the closest x-axis. So in this problem, it's either this one or this one, which is 90 degrees, or in other words, pi over 2. So we're doing the cosine of pi over 2. So I don't know if you noticed, but on example 1 and 2, you would have mostly thought to use pi over 4 as a reference angle, but in this case, it's actually pi over 2. So keep that in mind. Sometimes it'll be the same one that you have in the problem, like for example 1 and 2. But on some problems, that won't be the case. So make sure you find the reference angle for every single problem. Now, the cosine of pi over 2. Let's go to our handle, let's label it. 0, pi over 2, pi over 3, pi over 4, skip 5, go to 6. Pi over 2 is our thumb, so you're pulling that finger back. Using your hand trick, cosine is square root of top fingers over 2. So since your thumb is pulled back, there's no fingers above that, so square root of 0 over 2. Square root of 0 is 0. 0 over 2 is 0. So the cosine of 18 pi over 4 is equal to 0. And since it's 0, you don't have to check your sign, since 0 is neither positive nor negative. For example 4, we're evaluating the tangent of 4 pi. First things first, let's draw our angle of 4 pi. So our angle is 4 pi, so half a revolution is 1 pi. 1 full revolution is 2 pi. So that should be enough to graph our angle. 1 full revolution is 2 pi. 2 full revolutions is 4 pi. So our angle starts and ends right here at the positive x-axis. So obviously our reference angle there is 0 radians. So let's go back to our hand. So 0, pi over 2, and of course I'm just labeling out so you can get some practice, so you can memorize that. Our reference angle was 0, so we are having our pinky pulled back. We're doing tangent. If you remember from the hand trick formula, tangent is the square root of bottom fingers over square root of top fingers. So again, your pinky's pulled back, square root of bottom fingers, which is square root of 0, over square root of top fingers, which is square root of 4. Simplify. Square root of 0 is 0. Square root of 4 is 2. 0 over 2 is 0. So the tangent of 4 pi is 0. Since our value is 0, do not check the sign because 0 is neither positive nor negative. So here's our last example, cotangent of 10 pi over 3. So let's graph our angle. Always start at the positive x-axis. 1 full revolution is 6 pi over 3. We're trying to get to 10. So half a revolution more, we're at 9 pi over 3. So we need 10, so we have to go down one more. The reference angle is from the terminal side to the closest x-axis, which is this one. So again, this right here was 9 pi over 3. We needed 10 pi over 3. Therefore, this is 1 pi over 3. So we're going to do the cotangent of pi over 3. So let's go to our hand trick. Let me label it. We are using pi over 3, so hold your index finger back. Now we're doing cotangent. Remember, cotangent is the reciprocal of tangent. So we are doing the tangent of pi over 3. Once we get that solution, we are going to find the reciprocal of that. So back to the hand trick, pull back your index finger. We're doing tangent. So tangent is the square root of bottom fingers over square root of top fingers. Now, since your index finger is pulled back, square root of bottom fingers is square root of 3. Square root of top fingers is 1. If you simplify that, you get square root of 3 over 1, which is the square root of 3. Now, let's check our sign. All students take calculus. Our angle landed in the third quadrant, and only tangent and cotangent are positive. Since we are doing the cotangent of 10 pi over 3, our answer is positive root 3. This is actually wrong because I forgot to do the reciprocal. So let me go back to this step. If I simplify that, I get square root of 3 over 1, but that was for the tangent. I'm interested in the cotangent, so I have to flip that, and I get 1 over square root of 3, and of course I have to rationalize it. So my final solution is square root of 3 over 3. And of course it's positive again because it lands in the third quadrant. So go ahead and try the following, pause the video, and then come back. Let's start by finding our reference angle. Keep in mind that on this problem we're doing negative 9 pi over 4. So now we're going to move clockwise. So this is negative 4 pi over 4. 1 full revolution will be negative 8 pi over 4. So let's graph the angle. Again, you start at the positive x-axis. Going clockwise, that's negative 8 pi over 4. You're trying to get to 9. You're going to move down to 1 more. So of course, making our reference angle pi over 4. So we're going to be doing the cosecant of pi over 4. And remember, the sine will be our reciprocal. So let's go to our hand trick. So let's label our radian. So pi over 4, 45 degrees. So hold your finger, your middle finger back. Sine will be the square root of bottom fingers over 2. And we have 2 bottom fingers. It doesn't reduce. But we're doing the cosecant, so you have to flip that. Then you have to rationalize it. And you get 2 root 2 over 2. Of course, that simplifies to square root of 2. Last thing to do, you have to check your sign. So the angle landed in the fourth quadrant, so it's all students take calculus, so only cosine and secant are positive. They're making this answer negative square root of 2. Now go ahead and try the last problem, pause the video, and then come back. So let's find our reference angle. Most likely it'll be pi over 6, so let's see. This is 6 pi over 6. 1 full revolution is 12 pi over 6. Each quadrant is 3. So let's graph our angle. Always start at the positive x-axis. It's positive 20 pi over 6, so we're going to go counterclockwise. 1 full revolution is 12 pi over 6. We're trying to get to 20. So 12 plus 6 is 18. We're trying to get to 20, so we're going to do 2 more. So this will be 2 pi over 6. So that's our reference angle right there. So of course, 2 pi over 6 reduces by 2. And you get pi over 3. So the reference angle there is pi over 3. So we're going to do the secant of pi over 3. And again, we can't do secant using the hand trick. So you have to use your reciprocal, which is the cosine. We're going to do the cosine of pi over 3. Then we're going to get a solution and flip it. So let's go back to our hand trick. Let me label my radians for practice. Pi over 2, pi over 3, pi over 4, pi over 6, and that's 0. Now we have pi over 3, so you're holding your index finger back. The cosine is square root of top fingers over 2. Since you're holding your index finger back, top fingers is 1, just the thumb. If you simplify that, you get 1 over 2. And the last thing to do is to flip it, get the reciprocal since you're doing secant, and you get 2 over 1, which is just 2. So the secant of 20 pi over 6 is 2. But let's check our sine. All students take calculus. Our angle terminated in the third quadrant, so only tangent and cotangent are positive. Since you are doing secant, your answer is negative 2.